Good afternoon. It's time for us to get started. Afternoon. Yes, so let's get started. Before we get into the lecture material, wanted to bring this to your attention. How many of you are part of the Institute of Industrial and Systems Engineering? No. So this is the, if you're in industrial engineering, this is the largest, we'll say the most important professional organization for industrial engineers. And yeah, I encourage you to join, because here you have a lot of opportunities as a student and also as a professional in the future. Some of the things that you can access through them are they give a lot of seminars, webinars online that if you're a member, you can join and you can take advantage of not only learning from your faculty members here at the Ingram School of Engineering, but you can also access these lectures from these people that are working in industry and also working in other universities. So once you join, you're basically entering these communities in which you can get access to all these trainings and webinars. The other thing that is available for students is scholarships. So I think we, Palani, apply for one of those. We had some difficulties. He was not able to continue in the competition, but so if you're a member, you also have an opportunity to apply for scholarships. We were thinking about that for several students coming year. So I'm also bringing this today because we have a chapter in the School of Engineering for the Industrial and Systems Engineers Society and the Institute, IISE. And we are gonna run some elections. You can participate in this as a graduate student. Yes, sir. Yeah, so for the memberships, if you click here, join IISE, this is at the professional level, the national organization. You have student memberships is $39 for a year. But this includes a magazine, a monthly magazine that you receive with, again, a lot of information about IE, and also give you the opportunity to access all these seminars, webinars, and also. So I will say, an investment. $39 for a student is I will say, is something that it will be worth it for you to do. Especially if you want to participate in these scholarships. So some of them are $3,000, $4,000, and there are multiple. I mean, it's not just one, there are a lot of them. So chances of getting one of those, if you have a good profile, is high. Yes. You have to submit I have information about them. Each one of them have their own requirements. You have to have a good GPA and you have to submit an essay. Excuse me? You have to apply and you have to submit an application. And it involves transcripts, it involves your CV, I think, and then you have to answer some questions also. Yes. But there are multiples, and then that's I will say, a good benefit. Also, there's trainings that are being held here. At least last semester we did it for one of the certifications. So if you're a member, you get a discount for those certifications as well. So again, becoming a member is important. Now coming back to the chapter that we have here in the school, There's going to be some elections tomorrow on Wednesday afternoon. You're probably going to get an email about that today. So the chapter in the School of Engineering is open for graduate students and undergraduate students, and the idea again is to set up a chapter. Well, we have a chapter, but we want to activate the chapter so we can have a larger participation of the students. Is a forum for discussing ideas, a forum for bringing companies to discuss opportunities, a forum for developing your leadership skills. So if any of you is interested of running for a position, we are gonna have elections on Wednesday. I think for graduate students it'll be good. We don't have a lot of participation from graduate students, so I think activating that from the graduate student perspective is also relevant. So, but more information is coming. I just wanted to bring this to your attention. So this is something that you should consider. Again, you get a magazine every month, and you get information about multiple things from the for the profession itself. Any questions, comments? Okay, so now going back to the discussion for today. We are gonna be working with schedules today using Arena. And what that means is, so far we've been assuming that we have a arrival pattern for the system that follows a specific trend throughout the simulation for the entire day. So for example, if an exponential 5 with a mean of 5 minutes, we assume that they will look the same. So it will follow the inter-arrival times, will follow that arrival pattern for the entire day. That's not always true. For manufacturing systems, for service systems, we know that there's some changes throughout the day in terms of the arrival pattern. So sometimes peak hours, if you're looking at a restaurant, lunchtime, dinner time will be peak hours, and then outside those time periods, you might not see as many customers, or you will see a set of customers, but it will not be that many when compared to those peak hours. So the idea for today's exercise is to represent those situations in the real life. So if you were to create a simulation model in which the arrival patterns are going to be changing throughout the day, how do you model that using Arena? And that's the question that we want to answer. The second question that we want to answer is, if you want to collect some information about a specific time of the day. So for example, if you want to know what is the working process at 6 p.m. or 3 p.m., in order to get an idea of what is the status of your system on a specific time of the day, how do you code Arena in order to gather that information? Things like, for example, if you're running a restaurant, you want to know how many people you have at peak time. Yes, sir.
You have left my backpack in here for us.
Yes, go ahead. So if you were to, you want to know how many people are inside the facility during the peak time, you can code that into Arena in order to gather that information from the system. And I'm going to teach you how to do that today. So those are the main questions that we want to answer today. First, how do you model, how do you represent a inter-arrival time that is changing throughout the day? Second, how do you code for getting some specific statistics from the system at a specific time during the day? So, so we're going to go through some of the slides that are more relevant for today. So we are going to get, we're going to use the create block, actually this block, to once we set up the schedule for the day, we're gonna come here and is in the type option, you'll see that there's an option that's state schedule. So you have the option of selecting a random distribution. You have the option of using an expression, and then you also have an option to use a schedule. So that's right here in the type. So for today's lab, we're gonna be using the option for schedule. But before we get into coding that into the create block, we have to create the schedule based on the status of the system. Okay, so we're going to be working with the schedule today. I'm sorry, with the create block and the schedules today. We're going to be using the assign block to create an assignment, an attribute that is going to contain the processing time for each entity. Bless you. So we'll see that today. So this is what we covered last time. So this is the new. So there are two types of schedules that you can code in Arena. The first type of schedule is for the arrival patterns. So these allows you to define an arrival rate based on a daily time or calendar. So this is typically what you observe also in an airport. Like you have more people arriving during the day than certain other hours. So entities arrive according to a schedule. So if you have a peak happening during a particular time of the day, you can represent that using these schedules. The other type of schedule is for the resource capacity. So this is basically telling you, okay, you're gonna have these many resources available during these times. And then if that needs to change during the day, you can also represent that. So it's not gonna be a fixed capacity through the entire day. This is gonna allow you to represent the different levels of resource availability throughout the day. Today, we're gonna focus on the arrivals. So generating these schedules for the arrivals. And then in our next lab, we're gonna focus on the resource capacity schedule. So what are the parameters for the schedules? We have to provide the name of the given schedule. So for example, if your schedule is focusing on the arrival patterns or is scheduled for the arrival rate, we have to provide that name. The type of schedule is going to be a duration. And then for the type, also we are going to specify that this is an arrival schedule. So this, what we're going to be representing in the schedule is going to be based on the arrival rate of the entities. And then there's also some additional parameters that are listed here. So for example, if you want to specify the time period, let's say your arrivals are changing every 30 minutes or are changing every hour or changing every 15 minutes, you can specify that in the schedule. Okay, so you're going to establish the time period that you want to use. Hourly, half an hour, and so on. You also have the scale factor. So for example, if you want to run different experiments, let's say you have a schedule already in place and you want to run an experiment that says, well, I want to increase these arrivals by 10%, following the same trends, but I want to increase the arrivals by 10%. You can do that using a scale factor. So that's the idea. So originally in Arena, this is something that I really like. They removed this from Arena, but I still keep this for illustration purposes because this gives you a good visualization of what we are trying to do. So what the Arena does, it assumes that you have a non-stationary Poisson process. Okay, so in which the interarrival times are going to be exponential. So what you need to provide Arena is with the mean of the Poisson distribution. So these are the number of entities that are arriving per time period. Okay, so for example, in here, I have a bar chart that is looking at a day is divided by hours. And for the first for the first 6 hours, I have a process that says you have 2 arrivals per hour. And then after the 6th hour, at hour number 7, that arrival increases from 2 to 4. So instead of having 2 arrivals per hour, I now have 4. And then after the 8th hour, this is saying that you get 8 arrivals per hour, and that's the same until the end of the day. So what we are providing the schedule, we're basically telling you're going to divide the day in these many periods. And I'm going to tell you how many arrivals I should expect based on a Poisson process, how many arrivals I'm going to get per time period, and how many time periods are going to be with that same interarrival rate. So Arena, now instead of providing you with this window now in which you visualize the arrival patterns, they decided to remove this. And now what they give you is a table, okay, with a value and a duration. So now instead of creating this graph, you had to do the graph manually or do the numbers manually and then input that information into Arena. So for example, here, I will do 2 arrivals for how many time periods? How many time periods do I have with an arrival rate of 2? Can you tell me? Nobody can tell me? You're not paying attention. What about online? Anybody can tell me how many time periods I have with an arrival rate of 2?
Yes, I'm here, but
there are 6. You have an arrival rate of 2. See that in the graph for 6 time periods. And then with a value of 4, I have 2. And then with a value of 8, I have 60.
60.
Okay, so in Arena, now you have to code this information in this format. But again, what this is trying to represent is an arrival rate that is changing throughout the day. So again, 24 hours, the first 6 hours, I have an arrival rate of 2 entities per hour. Then after 6 a.m., that increases to 4 arrivals per hour. And then after 8 a.m., that increases to 8 arrivals per hour. And then it continues in that way until the end of the day. So the idea that we're trying to represent in this model is that changing arrival rate throughout the day. So in Arena now, instead of getting this plot, we're going to have a table like the one that I created at the top that is representing that trend. So once we define the schedule, the arrival schedule, we are gonna code that into the create block. So as you can see here in type, I have the schedule, and the schedule name is the name that I give to my schedule, in this case, a schedule. And that will basically create the arrival pattern that we want. Statistics, you're really familiar with this. Let's see. There's something that we have to do new today. I'll probably show you how to do that in the example. You already know this. So this is the example, and I want you to pay attention to this, because now the mean number of customers is not the WIP for the entire day. This is the WIP at 6 p.m. So we are going to be running a 24-hour process in which we have a non-stationary arrival process that is going to be changing. So this is the arrival rates. So we have 4 arrivals per hour from 12 to 10 a.m. and then 10 arrivals per hour from 10 to 6. And then 8 arrivals per hour from 6 to 12 a.m. We have a 24-hour store. That gamma distribution, what it's representing is the time the customers spend inside the store. So this is more like a delay. And then after the customer stays in the store for that amount of time, it goes to the cashier. Okay, so we have a single cashier, and we have 50% of the customers will take 2 minutes to pay. That is here. And 50% of the customers will take 5 minutes to pay. So that's the description. The model itself is not difficult. So you have these arrivals happening at different times of the day. Customer will spend some time inside the store, and then they will go to the cashier. They will submit their payments, and they have different durations for the processing. So 5 minutes, let's say you're paying in cash, 2 minutes if you're paying with your credit card, and then you're counting them. So there's several things here that we want to address. We're going to run this for 10 replications. Each replication is going to be 10 days per replication. And we are going to give a priority to the shortest time first. So that will be for the cashier. So we want to take care of the people that spend less time first. I'm going to show you how to do that. And then let's see what else. We are going to compute these statistics, mean number of customers in the system, and then mean number of customers at 6 p.m. And then we're going to compute the average cycle time. So that's the exercise. Let's see if we can work on this. So let's open Arena. Okay, so we are gonna start our model. See, we are gonna have a create block. Remember always to save your file. Okay, so we are gonna start with our create block, but we are not gonna edit this because we have to create the schedule first. So we can go to the basic process and find the schedule. If you click on schedule for the module, and you want to build the schedule for this, you have to double click here. The first thing you have to do is to provide a name for the schedule. So we are gonna call this arrival schedule. For the type, the default for the type is always capacity. So if you're creating an arrival schedule, you have to switch to arrival. And then in our case, we are using hours because our schedule is defined in hours. But if you need to define this in a different time frame, you have the option of using seconds, minutes, quarter, hours, half an hours, hours and days. We're gonna keep it with hours. And the scale factor, again, one means that you're gonna use the arrival rates that are given. But for example, if you want to increase this by 10%, you can use 1.1, and that will increase the arrivals, for example, from 4 an hour, 4.1, and that will, the arrival, the mean of the arrival will be 4.1, and that will increase the number of arrivals that you will have per hour. So remember, this is a Poisson process. So if you remember the Poisson distribution, just go ahead. The scale factor is there if you are running experiments, for example. Let's say you're running this with the number, with the default numbers, right? And you get the results. And then you want to say, okay, what if I increase the arrival rate, right? And instead of going into changing the numbers of the arrival means, you can just say here, let's increase that by 100%. And you do 2, and that will increase the number of arrivals from 4 to 8 per hour, right? Yeah. So instead of changing the arrival means for every experiment, you can just change the scale factor and run different scenarios. For now, we can just say 1. And then we are gonna click here for durations. And this is what I was referring to here. You remember, originally we used to have this window that will make a visual representation of our means throughout the day. Now we have to create a table like this. Okay, so for this, we have to agree on what we are going to be using at time 0, right? So for time 0, if you go back here to the description of the problem, if we use midnight as time 0, then we're going to start with 4, and then after 10 hours, I'm sorry, after 10 a.m., we're going to change it to 10, and then after 6 p.m., we're going to change it to 8. But that's decided by the user. Okay, so you can use as time 0, you can use 10 a.m. or you can use 6 p.m. It doesn't matter. Okay, you can choose your time 0. If you are consistent, you should get the same results. Okay, so we're going to choose 12 a.m. as time 0, 10, and then 6 p.m. Why is this important? Because that's going to affect on how we collect the information for number 2 here, mean number of customers at 6 p.m. If we choose 12 a.m. as time 0, then that means that we need to collect the statistics 18 hours after we started. But if we choose 6 p.m. as time 0, then it's time 0, right? 6 p.m. is time 0. So again, you have to make a decision and then remember that decision, because everything else that you're going to be coding has to be consistent with that time frame. So we're going to use 12 a.m. as time 0. And we're going to build this table. We're going to start with 4 arrivals, and that's going to last 10 time periods, right? So from 12 to 10 a.m., those are 10 hours. From 10 to 6 p.m., those are 8 hours, and that's going to change to 10. So the second row is going to be 10 arrivals per hour for 8 hours. And then for the last one, we have a value of 8 for 6 hours. Okay, and that's the schedule right there. We can close this. If you close that and you click on the 3 rows, you will have the same information. So now when we get to this part, we go to the create block, we chose schedule, and then we search for arrival schedule. Okay. So that covers the create block. After that, we have to do some assignments here. So let me find an assign block. I'm going to define an attribute because I need to collect some information here for the cycle time and for the working process. So I'm gonna create an attribute that is called arrival time. And this is gonna be T now. This is to assign the arrival time to each entity. And I'm also creating a variable for the working process. And this is going to be WIP plus 1. Okay, so after this, what we have here is some information about the delay, right? So we need a process to represent that delay. So this is going to be a delay following a gamma distribution. So I'm going to use an expression in minutes. I'm going to find the gamma. I think this is 5 and 4. So the customers will spend some time in the store, and that model using this gamma distribution with 5, beta 5, alpha 4. And then after that, they'll go to the cashier. But this is just a delay. It's not a resource. For the cashier, we need to build a resource, sys delay release. We're going to call this cashier. Yes, we'll get to that because that's more for the statistics. So minutes. And these guys. Yes, so the cashier is going to spend time based on the attribute. Yeah. So as you were saying, we cannot fill out this yet because we're going to use an expression for the amount of time. So let's skip this here. We need to build some logic before that are going to allow us to model the difference in processing times for each customer. So as you were saying, we need a decide block that is going to split the units 50%. It's good. And is going to we're going to have an assign block here and a assign block here. And this is going to call a new attribute that is called processing time. And you'll see how this is going to be used. So for 50% of them, the processing time is 2 minutes, right? So we are modeling that processing time here with this assign block. So for a group of them, the processing time is 2 minutes. For a group of them, the processing time is 5 minutes. Okay, so this assign block, the second assign block is going to use the same attribute called processing time. But the value for this second assign block is 5. And we're going to connect this to the second branch of this decide block, and then both of them will go into the process. So the idea here is representing this difference in processing times. Like 50% are 2 minutes to pay, 50% is type B, 5 minutes to pay. So now we use an attribute to represent the processing time for 50%, 2 minutes. The other 50% is 5 minutes. Now, when we go here into the second process, the time that they're going to spend in the cashier is going to be depending on the type of entity. So what we are going to do is that we're going to use this expression, and the expression is going to call the attribute. So we're going to have to type that attribute here. Processing time. Processing. Process 2. Choose the expression, and then you call the attribute processing time. If an entity has a processing time of 2, it's going to be 2 minutes. If the entity has a processing time of 5, it's going to be 5 minutes. Very good question. So the attribute is the same, but the number is changing. The value of the attribute is changing. So remember, the attribute is something that you assign to the entity. So if the entity goes through the branch at the top, when you assign a value to that entity, let's say it's 2, that number is not going to change. If you go through the bottom, processing time is 5, that number is not going to change. That number is going to be carried by the entity. So when it gets to that block, what the process is going to do is going to open that entity, is going to search for the value, and is going to use that value. Okay, so even though it's like if you're coding, you have an attribute, let's call it an integer, right? So you can assign any integer to that value, still an integer, but the number will change. Good question. So processing time, and then you call this here, and it's going to open that attribute, and it's going to use the value for that entity. Okay, so we have our resource. Okay. So this is something that we're gonna test, right? But let's work with this. So if you remember here, it says priority shortest time first, right? So how do you code that priority into this cache here? You have to go find the queue for that process. This is process 2, the queue. And then you want that queue to be organized according to something. Yes. And then you have to choose the attribute. Processing time. So what this is going to do is going to go to that queue. It's going to search for the attribute. If you have a small value, you're going to go first. If you have large value, it's going to put you on the back. Okay, so this is small detail. It'll be hard to remember, right? But you're practicing now. So if you have a priority for the entities in the queue, you go to the queue module, you find the queue, and then you select the type of queue that you want to have. In this case, lowest attribute processing time, and that would be put priority into those. Okay, so after this, we get the statistics. So let's put the assign here for the working process. So it's a variable working process, WIP -1. So that will reduce or decrease the working process. And then we have to collect the cycle time. So let's use a record. We're gonna have here a time interval. And we're gonna use the arrival time. And the time tally name is cycle time. Yes. So assign for is just WIP -1. Okay, so we can connect these two. And then after this, we can just dispose. No, should get the same numbers. Okay, so far, let me save my model. I want to check my model. See if I have any errors at this point. Oops. Really? Try again. Huh. Okay. Yeah, this is a new machine. I mean, it's the same machine I was using before. Same model. Yeah, I remember. This is the first time I've seen this. Yeah. I'm glad I saved it. You see. Okay, so you guys get any errors? No. See. So if I run it, does it work? No. Okay. Okay, so let's see. If I set up the model, let me see if this will work. Yeah. Set up, run control project parameters. So I'm gonna uncheck this. Entities. Replication parameters 10. Replications 10 days. Base time units in minutes. Okay, And then for the reports, so if I run, okay, so I apologize for this. Let's see, I got a chat. Okay, so I got a student with the same problem. Okay, so let's try to complete the model. At least you're following. If you're doing the same thing, then you should be able to see the errors. Yes, so let me open the model. So for the setup, you're gonna uncheck all this. And for the replication parameters, it's gonna be 10 replications for 10 days. And this is gonna be minutes. You have questions? Okay, so, and then for the reports, let me apply this. Assignment. Okay. Save this. View. Okay, but we're not done yet. We another message. Okay, so let's set up the statistics. So we're gonna set up the statistics here. The first thing I wanna do is a time persistent for the working process. And the report label is gonna be work in process. Okay, so you got that one, the working process. Okay, so number 2, I want to do an output for that statistic. So this is going to be the ABG. And this is going to be work. Okay, you got that one too, the output. Okay. Then I have the cycle time. Cycle time is an output. TABG cycle time. You got that one? The cycle time? You coded all this already? I'm behind. ABG. And then for the last one, what did you do? Okay, so for the 6 p.m. Good. So let me save this. So I have the working process and the cycle time. Now we have to find the cycle time at 6 p.m. And what we want to do, I have another message here. Okay, so another, so this is what we are running our model for 10 days, right? So every day we need to collect an observation at 6 p.m. Does that make sense? Okay, so what we want to do is we want to run the model 6 p.m. We're gonna get a number. We're gonna put it in a bag. On the next day, we're gonna do a 6 p.m., get the number, put it in a bag. Next day, and we continue. At the end of each replication, we should get 10 numbers because we are running this for 10 days. Does that make sense? Okay. So even though this is a working process, the way we are collecting this now is not a time persistence statistic. You see what I'm trying to say? Because now we are not worried about the change throughout the day, right? It's not a time persistence statistic. What we're concerned about is a single observation that is happening at a particular time of the day. So we're gonna collect an observation, we put it in a bag, observation, put it in a bag. So we're gonna use a tally to collect this information. The second thing is that we're gonna create a separate logic for collecting this information. So this is what I'm referring to. We are gonna use a separate create block. This create block is not representing something real. This is like a dummy logic that we're gonna use to collect some statistic for the model, from the model. So we're gonna use a create block. We're gonna also use a record block. And also we're gonna use a dispose block. So this separate logic is built just to collect that information. So an entity will be creating the signal for the model to collect the information. Okay, so we're gonna use a daily entity. What this means is that every 24 hours, I'm going to generate an entity that is gonna send a signal to the model to collect that information. Okay, so every 24 hours, I'm going to generate an entity, right? But I want my first creation to happen at 6 p.m. Since my origin or my time zero is midnight, 6 p.m. is gonna be the 18 hours, right? From time zero, right? So it's 12 hours till noon and then 6 more hours. So 18 hours. So my first creation is gonna happen at time 18 hours. And then what's gonna happen is I create my first entity at hour 18, and then every 24 hours, I'm gonna send another entity. Every 24 hours, I'm gonna send another entity. So every 18 hours, every day at 6 p.m., I'm generating an entity. Every day at 6 p.m., I generate an entity. That entity is going to be sent to this record block. And what this is going to do is going to use this expression. It's going to collect the value of the whip. And it's going to put this, let me call this whip 6 p.m. It is the whip, yes, is the value. So it's gonna call that variable and it's gonna say, okay, tell me the value at this time. It's gonna say, okay, whip right now is 100. So it's gonna take that value and it's gonna pass it to the record block. And every 6 p.m. at 6 p.m. the next day, it's gonna do the same thing. You generate an entity at 6 p.m. and it's gonna tell the record block to go collect that number from the whip. So I'm calling this whip 6 p.m. And then that entity is going to be disposed. So if I go to statistics now, I can complete this. It's going to be an output, TABG web 6 p.m. And this is going to be average work in process 6 p.m. Save this. Run it again. Not gonna do it. So check if your model gives you any errors. Try mine. Okay, so run it now. Let's see your numbers. So we're getting much 4.61 or width or 60. Okay. 4.61 for the working process at 6 p.m. Cycle time, how much you got? Yeah, I think that's because the number is not average web, the general. No, those numbers are too high. So your cycle time is good, but the web is too high. So are you doing minus in the assign? Here, make sure that you're doing minus instead of plus. I think that should fix the problem.
Oh, yes.
Yes?
I changed it.
Okay.
Yeah. I got the number. Sorry.
Okay, awesome.
Yeah, I switched to
Questions,
plus to
comments?
minus.
Good. So that's all you need for the next assignment. Now I want to spend some time talking about the project. Okay, so remember that your next project report is due on April the 5th. So I'm sorry, April the 4th. So that's a week from today. So I sent you a report that was submitted by a student in 2016, an old project, but it follows, I think is representative of what we are expecting or what I'm expecting from you for your report. So let me open. So the project report as an introduction, that data collection, how the data collection process was taken. So basically describing what information was collected for the input modeling, and then what information, historical data was collected from the system in order to perform the validation. So for example, I mean, it will happen in the same way. So if you follow the cycle time for all your customers, at the end, you can compute an average. When you build your model and you run your model, the cycle time that you observe in the system should be similar to the model numbers when you're running the simulation. That's how you validate your model. Second or the okay.
So I didn't write the server number. I write the customer number, timing, service status.
Okay. Okay. But
They are using like one song.
yes.
Usually working like 2 hours.
Working. That is another system, but there are also cashier. But after some time, then another cashier came and started. After 30.
Okay. Can you at least identify which customers were served by each cashier or not?
Collected like 50.
Oh, yes, but I mean, you can mark this customer was, yeah. I mean, there are ways. You don't necessarily have to put a name, but you can say, okay, 1, 2, yeah. Yeah. Yes. So again, the idea is that if you know that happened in your system, then you at least know when to draw the line. This data was collected with a single server. This data was collected with 2 servers. Because you know, if you have 2 servers, cycle time for the customers should decrease, right? Because now you have more people serving. So at least you can make that distinction. If you're computing the statistic with a single server and with 2 servers, you can separate that. I mean, processing times, what I'm referring to is because if the arrival time and the queue time will change if you have 2 or 1 server, right? Queue times will be impacted by that change. So those are, I mean, somehow you have to draw the line in terms of this happened, like when you set up this table. In this case, they have multiple servers, but you at least can identify from this point on, we have 2 servers. From the beginning till this point, we have 1 server. From this point, we have 2. You at least need to make that distinction. Yeah. No. I mean, if it is changing, I mean, it depends. It depends on your system. Like a second, 2 seconds, 15 seconds can make a difference. Mhm. Yeah, I mean,
The customer, I can't keep.
It should be like 1 or 2% for the one.
yeah, and that's part of the process. Like the comment was that it was difficult to follow a multiple customers at the same time, and that's true. And then yeah, this is a practical experience. When you go do this in reality, you know that for data collection, you need to have multiple people. Yeah.
The question is like for
So what is your system? Okay, so what is the problem? Only one server? Only one cashier? What do you mean? Like, yes. But you're observing this for the same time period, right? So if it's changing 2 hours, I think that's the time period that you're observing, right? So that shouldn't make a difference. Remember that you have to observe during the same time period. Yeah. So here's day 2. And then the data analysis separated. So you can look at this on your own, but then here are the tabulated values for the interarrival times. And then he put that into the model and found the distribution, the variable. And then for the processing time, he did the same thing, tabulated the values, and then fit the distribution for the processing times. Server 2 did the same thing. And server 3 did the same thing. And has server 4, so it has the same thing. Verification and validation. So as you can see here, he's using the cycle time to validate his model, the queue time as well, and the service processing time. So after tabulating this information, he got the average cycle time, the average cycle time per hour, average wait time, and average wait time per hour. And did that for multiple days. But what I'm getting to is to this. So here we have the summary. So for each item, it has a distribution associated with each item. So for servers, processing time, there's a distribution, and then for the interarrival time, there's a distribution. Okay. So we have time, you know, on Wednesday, we can separate some time to answer your questions. But my recommendation is to go through this, and then hopefully you have some data already collected, so you can start putting your report together and build your arena input models based on that. Have some chats here. Yes, the question is, should I record in the same time period? Yes, the answer is yes. So you should identify a peak time, and then your data collection should be happening during that time period. If you're gonna go for multiple days, you have to go during the same time period, because that's the only way that you will make sure that you're observing the same type of behavior.
Again, to not other than false, I can go now.
Yeah, so that's the thing. You have to observe the system during a peak time. And if you want your data to be consistent, you have to observe the system during the same period. If you go now, maybe, I mean, if you observe during lunchtime, you will expect to have a high volume of people there. But if you go at 4 o'clock, even if you're observing the system, the number of people that will be there is much less. So if you're trying to fit a distribution and you have these two patterns that are completely different, you are not gonna get a good fit. See what I'm saying? You have to observe the system during the same time period. in order to make sure that the data is consistent. So when you fit the model, you get a good fit. If you observe one day, let's say you go to lunchtime, and this is number of people. Right? So you will see something like this happen. But then you start to go, say 3 p.m. to 5 p.m. Number of people here. So now you are combining these two data together. They are different. We should observe like day 1 looks like this, day 2 looks something like this, day 3. These are different days, but they're following the same behavior. You don't want to have something like this and then one here and then one here, because when you try to fit the distribution to this, you're not going to be able to get a good fit.
Other than that, when is the big thing?
It depends on your system. So if you're observing a restaurant, typically you get that during lunch time or dinner time. I'm not sure. But you have to pick one. You have to pick one. If it's dinner, it's dinner. If I'm not sure. I'm just guessing. Like for me, it'll be 6 p.m. on 6. Yeah. Yeah, but here for the restaurants, I'm not sure. I know lunchtime is always busy, but in the afternoon, I'm not sure. Okay, so I'm stop sharing now. I'm gonna stop the lecture. We are going to continue on Wednesday. And if you have questions about the project, you can bring those on Wednesday. We can clarify your questions also on Wednesday. Okay, so I'll talk to you more on Wednesday.